Okay, this is section 6.6, trapezoids and kites. So again, this whole chapter 6 is on quadrilaterals. We've spent most of chapter 6 so far talking about parallelograms, and falling under parallelograms have been rhombuses, rectangles, and squares. Now we're going to talk about some quadrilaterals that are not parallelograms. Okay, so again, trapezoids and kites are not parallelograms. They don't have the parallelogram properties. They have some new properties that make them unique. So a trapezoid we're going to start with is a quadrilateral with exactly one pair of parallel sides. Okay. Two parallel sides of a trapezoid are called bases. The non-parallel sides are called legs. I'm going to show you these in the picture in just a second. We'll just get this filled in for now. And then two angles that share a base of a trapezoid are called base angles. And a trapezoid has two pairs of base angles. Okay, so if you look over here, again, we just said a trapezoid has one pair of parallel sides. Okay, and I can see that with the little arrows here. Okay, these other two sides are not parallel to each other. Okay, so the sides that are parallel are called bases. The two sides that are not parallel to each other are called the legs. And then we have some pairs of base angles. So these two angles are a pair of base angles because they're angles right beside one of the bases. And these two angles are a pair of base angles because they are beside the other base. Okay, so each trapezoid has two pairs of base angles. All right. Then more specific than just a regular trapezoid is an isosceles trapezoid. So just like we've talked about, isosceles triangles have two congruent sides. An isosceles trapezoid is a trapezoid with legs that are congruent. So if we look at this picture right here, we can see it's a parallelogram because it has exactly one pair of parallel sides. And then we can see these congruent marks here that show me those legs are congruent, and I therefore know that that has to be an isosceles trapezoid. If we look down here, this theorem says if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So again, I see that it's a parallelogram, I see the legs are congruent, and so therefore I know, again, parallel, parallel, congruent, congruent. I know it's an isosceles trapezoid, so this pair of base angles must be congruent to each other. And I can see that it says T is congruent to P. And I can see that this pair of base angles must be congruent. So angle A is congruent to angle R. Okay? So that information is going to come in handy when we're dealing with trapezoids. So if I go and get that cleared and moved up, we can try example 1. That's pretty quick. So, on example 1, it says QRPS is an isosceles trapezoid with angle R is 106, and they already have that filled in the picture for me. And then I'm going to fill in the missing pieces here. So I can see that one pair of opposite sides is parallel. I can see that the legs are congruent, so I therefore know that it has to be an isosceles trapezoid. And we just said if it's an isosceles trapezoid, then I know that this pair of base angles must be congruent, and I know that this pair of base angles must be congruent. Okay, so I know that if this is 106, then this has to be 106. And I'm going to write that here. Angle S has to be 106. Okay, or actually measure angle S. All right, from there, I know that if these two lines are parallel and that is a transversal, then I know that these two angles are same side interior angles, so they must be supplementary. Okay, so in this case, I know that the measure of angle P plus 106 has to equal 180, and when I solve for that, then I get measure of angle P is 74. And I can fill that in on my picture once I find that. And then from there, I already said that these two angles were congruent. This pair of base angles is congruent, so that must be 74 also. And I can include that as well without having to do any extra work. Okay? All right, the last bit on this page says that if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. If you remember, a rectangle had congruent diagonals as well. So I can see it's an isosceles trapezoid with the one pair of opposite sides parallel. I can see the legs are congruent. And it's just showing me here that AC, this diagonal, must be congruent to BD, this diagonal, if it's an isosceles trapezoid. It's almost like it's just standing up straight. Those congruent legs make it stand up straight, and therefore it makes sense that those diagonals would be congruent to each other. Okay, if we go and get that cleared. Moved up here. We're going to talk about the mid-segment of a trapezoid. So in this case, it says a mid-segment of trapezoid is a segment that joins the midpoint Actually, that's not copying very well. Let's try again. Okay, that looks a little better. Midpoint of the legs. All right, so if we look at this picture, it says if a quadrilateral is a trapezoid, then the midsegment is parallel to the bases, and the length of the midsegment is half the sum of the lengths of the bases. Okay, and this picture shows that well. This M is the midpoint of R and T, and I know it's the midpoint because this piece is congruent to this piece. N is the midpoint of A and P, and I can tell that because this piece is congruent to this piece. Okay, I also know if it's a trapezoid, then the bases must be parallel to each other. And if those are parallel, then the midsegment is also parallel to the bases as well. And from there, it's giving us a little formula here. The length of the midsegment is half the sum of the lengths of the bases. Think of what sum means. It means add. So again, it's telling me that all three of those lines must be parallel to each other. And it's telling me MN, the midsegment, the middle piece, is equal to 1/2 of TP, this base, plus RA, this base. The sum of those, so add up the two bases and then half it or divide by 2. It makes sense that this piece would basically be the average of these two. Okay, so again, whatever these two are, this should be right in the middle. Whatever this number is should be the same distance away from this number as it is from this number, if it's right in the middle. Okay, so let me go and move this up to make sure we have plenty of room to do this one. But when we're doing this one, we're using this formula here. Okay, so let's get that moved up. Okay, so on this one it says MN is the midsegment of trapezoid QRSP. What is X? So what we just said is that if MN is the midsegment, I'm going to write 2x plus 11, that midsegment is equal to, actually I'm going to write it in letters first. Sometimes that helps people. So I'm going to say MN, okay, the midsegment is equal to 1/2 of the two bases added up. So QR plus PS. Okay, so sometimes it helps people just to write it in letter form first, and then they can start substituting things in. All right, so I just wrote MN, that's my midsegment, is equal to 1/2. And now I'm going to add together my two bases. So 10 plus 8x minus 12. Okay, and now I'm just using my algebra to solve for x. Okay, when I do that, I'm going to go ahead and combine my like terms together here, keeping everything else the same so far. So if I want to write the 8x first, I can, and then 10 minus 12 is -2. Okay, from here you have a choice. Remember with algebra, a lot of times there's more than one way to solve an equation. So one person might choose to multiply both sides by 2 to get rid of that fraction, and then some people prefer to distribute the 1/2. I've kind of found that most people prefer to distribute the 1/2. I probably kind of like to multiply the 2 on both sides, but either way is going to give you the same answer. So if I distribute the 1/2, then I end up with 2x plus 11 is equal to 4x minus 1. Okay, if you end up getting a decimal there or a fraction, that's fine. Again, if you don't like dealing with that, then you can multiply by 2 on both sides. Okay, from there, I can go ahead and subtract 2x from both sides. So I got 11 is equal to 2x minus 1. And then from there, I went ahead and added 1 to both sides. I'm running out of room, so I'm going to come up here. If I add 1 to both sides, then I get 12 is equal to 2x. And then once I solve from there, I get x is equal to 6. Now, this particular question is just asking me what x is equal to. It didn't ask me what the actual links are, but sometimes they will ask you what these links are, and sometimes it's just good to go ahead and double check. It doesn't take long. I know this length is 10. You know, I can see that. If I take the 6 and plug it in here, 6 times 2 is 12, plus 11 gives me 23. Okay, and then if I take my 6 and plug it in here, I've got 8 times 6 is 48. And if I do 48 minus 12, I got 36. Okay, and again, this link should be right in the middle of the other two. Okay, which it looks like it's right in the middle, but I can double check for sure. How far is it from here to here is 13. Well, how far is it from here to here? It's 13. So again, double checking to make sure this is right in the middle of these two is a good thing to do. All right, for a kite, the next thing that's mentioning here is a kite is a quadrilateral with 2 pairs of consecutive sides. And 2 pairs of consecutive sides congruent, and no opposite sides congruent. Okay, so again, we're talking about quadrilaterals in this section. We already mentioned a trapezoid, now we're mentioning kite. Both of these are quadrilaterals, neither one are parallelograms. All right, so this is some new information. It's a quadrilateral with 2 pairs of consecutive sides. We used the consecutive word the other day, which we said right beside each other, like consecutive numbers, 1, 2, 3. So consecutive sides right beside each other. So 2 pairs of consecutive sides are congruent, no opposite sides are congruent. So here we're seeing these 2 sides are congruent and those 2 sides are congruent. Kind of 2 shorter sides, 2 longer sides. Okay, it's also telling me if the quadrilateral is a kite, then the diagonals are perpendicular. That was similar to a rhombus. We said anytime we see these diagonals, we're automatically going to, if we know one's a right angle, we know that all 4 of those must be right angles if it's a kite. Okay, so let me get that cleared and moved up. Way here. And this is a little more information about a kite. Okay, so here it says a kite has 1 pair of opposite angles congruent and 1 pair of opposite angles bisected by a diagonal by side, side, side. So this gets into congruent triangles that helps make some of this true. So we see what's going on here. 1 pair of opposite angles is congruent by side, side, side. And in this case, you know, we can see it's a kite. These consecutive sides are congruent. These consecutive sides are congruent. We already talked about these diagonals being perpendicular, so these are right angles. And then it's saying 1 pair of opposite angles must be congruent to each other. So this is the pair of opposite angles that must be congruent by side, side, side. And where that is coming from is if I look at this triangle and this triangle, I can see congruent, 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 and they share that side. So again, if the 2 triangles are congruent, it goes back to chapter 4, then any of those other corresponding parts must be congruent by CPCTC. So therefore, this angle must be congruent to that angle. Okay? The next thing it's talking about here is that one pair of opposite angles is bisected by a diagonal by side, side, side. So these two angles are not congruent to each other. So in between the 1 and 2 mark, in between the 1 and 2 mark, in between the non-consecutive sides, those angles are congruent. In between the two, again, we know that side's congruent to that side's congruent to that side. In between these two congruent sides and in between these two congruent sides, this whole angle is not congruent to that whole angle. I don't want to think that, but I do know that this diagonal is bisecting this angle, meaning this angle is congruent to this angle. And I know that this diagonal is bisecting this whole angle, which means this one is congruent to that one. Okay? And again, that's by side, side, side. Also, because I can see that, I can see that in this case, like these two triangles must be congruent to each other as well. And I can see that these two triangles must be congruent as well. Okay? Then I can use some of that information down here to solve for missing pieces. So in this, and sometimes there's more than one way you can solve these. Sometimes people have a preference of one over the other. But in this particular case, I can use the fact that I know that the one pair of opposite angles are congruent. In between the non-congruent sides, those angles must be congruent. So if that's 110, that's 110. Okay, so that part's pretty quick. And in terms of figuring out angle 2, there's multiple things you can do here. You can either use the fact that if it's something that you know that a quadrilateral always adds up to 360, you could do that. That this plus this plus this plus this is equal to 360 and solve, if that's something that you know and remember. If not, what some people like to do is split this down the middle. And for some people, that's easier for them to think of. They knew that if this whole big angle was 98, then if I just halved it, just like we're talking about here, that these must be congruent, then this must be 49, and that must be 49. And I know that this is a triangle that must add up to 180, so say I want to call that x right there. Then I could say that 110, I'll say x plus 110 plus 49 is equal to 180. And if I use that to solve for x, then I'd end up with x is equal to 21. Okay, so I know that that is 21, and therefore I know that that angle is 21 also, but they want to know what this whole angle 2 is, so I know that measure of angle 2 is 21 plus 21, which is 42. Okay, so again, sometimes there's more than one way you can solve for it. Again, you could have treated the fact that all the angles of a quadrilateral add up to 360, or you can split it into two triangles and solve that way. Okay, on example 4, I can tell it's a kite. These two sides are congruent. These two sides are congruent. It looks kind of a different kite, but it still fits the properties of a kite. When I see these two diagonals, I automatically remember that property that says diagonals are perpendicular. So I'm automatically going to stick some right angles in here. And so already I know that measure of angle 2 is 90. I can get that filled in right away. Okay. Now if I look at the picture, I can see a triangle and I know two angles and I want to know the third angle. So I can use the triangle angle sum theorem. I can say measure of angle 1 plus 90 plus 48 equals 180. And if I solve for measure of angle 1 there, then I end up with 142. Okay, I can put that in my picture. And then the other thing that we talked about is that, again, this diagonal bisects this pair of opposite angles. So I know, got that one. I know that if that's 48, then angle 3 must also be 48, because again, these are congruent triangles right here. If that's 90, that's 90. You can also think of these as isosceles triangles. Here's an isosceles triangle. If that's 1 to 42, that's 1 to 42, because base angles are congruent. So therefore, if that's 48, that's 48. So measure of angle 3 is equal to 48. So again, that's kind of a key thing to keep in mind here, is that there's a lot going on here. I know these two triangles are congruent. I know these two triangles are congruent. I know that triangle is congruent to that triangle. And I also know that this angle is this triangle is an isosceles triangle. So if these two sides are congruent, those two base angles are congruent. And I know that's an isosceles triangle. So if those two sides are congruent, then those two angles are congruent. So there's a lot of information going on there. Okay? All right, let me go and get that cleared. And then we have one more summary sheet to go over that kind of helps you get the big picture of all of this. I think it's going to clear for me. Just thinking about it. Just thinking, there we go. Okay, so last page here is a summary page. And I know we filled out a summary page in section 6.4 the other day. But this is another summary page that might be helpful to you, that also includes the information about the last one just had parallelograms on it, and this one also includes the things that are the trapezoids and the kites that are not parallelograms as well. Okay, so I can't fit it all on the page, but we'll kind of do the top half and then we'll go to the bottom half. So again, all of these figures we're talking about in this chapter are quadrilaterals. Okay, which are again four-sided figures. All right, the first set we talked about were parallelograms in section 6.2. Okay, we said it has two sets of parallel opposite sides. Some characteristics we said of parallelograms is that opposite sides are congruent. The diagonals bisect each other. Let me fix a couple of these real quick. My pen's getting carried away. Okay, so that should be congruent, and that should be a better bisect. Okay, then opposite angles are congruent, and consecutive angles are supplementary. Okay, there's one other we had on the page yesterday that I said you didn't need to worry about it because we didn't cover it in section 6.3. But if you're wondering why it's not here, you can add it if you want. One pair of sides is both parallel and congruent. So the next type of quadrilateral that we talked about was a trapezoid. Okay, and it has one set of parallel opposite bases. And then more specific than just a trapezoid is an isosceles trapezoid. Okay, and it has exactly one pair of congruent opposite legs. Okay, and that's what specifically makes an isosceles trapezoid. The next set of quadrilateral that we talked about was a kite. And if it helps you to draw pictures of these and label these things on the pictures, that might be helpful to you. There's one other page that we're going to share with you as well that has a lot of pictures on it instead of a lot of words, and that might be helpful to you as well. It's nothing for you to really fill in, but it might be a good resource for you to use. So a kite has no pair of opposite sides parallel, and two sets of consecutive sides are congruent. Characteristics of a kite has one pair of opposite angles congruent. The diagonals are perpendicular. I'm just going to do the upside down T. And one pair of opposite angles is bisected. Okay, bisected by a diagonal. And that didn't quite copy very well. All right, and then We have none. So there are some quadrilaterals that are four-sided figures that are not parallelograms, trapezoids, or kites. They're just some random quadrilateral four-sided figure, and that's an option too, okay? But we're just not getting into those as much now. All right, so I'm going to move this up, and then we can fill in the bottom part of the page that includes the rectangle, rhombus, and square, just to give you a resource that has everything on one page. It's thinking about it. There we go. All right, so oh, I guess I didn't get this down yet for the isosceles trapezoid. Okay, let's get that filled in first, and then I will move that up a little bit here. So we already had isosceles trapezoid here. Okay, and we already said exactly one pair of congruent opposite legs, but we didn't fill in those characteristics yet. Diagonals are congruent, we couldn't see it a moment ago, and two pairs of base angles are congruent. Okay, now we're going to move it up and we can finish the rest of this page. Okay, so last little bit here is a rectangle, has four right angles. We know its diagonals are congruent to each other, and the other parallelogram we talked about is a rhombus, and it has four congruent sides. And the other things we said about a rhombus is the diagonals are perpendicular, again upside down T, and the diagonals bisect a pair of opposite angles. Bisect a pair of opposite angles. Okay, and then we said that the last one down here is a square, and we said a square shares the same characteristics as the parallelogram, rectangle, and rhombus. Okay, and again, if it's a square, it has all the properties of rectangle, rhombus, and parallelogram above, but again, it does not have the properties of the trapezoid and the kite. Okay, so let us know if you have any questions, and we'd be glad to help you out.